Hi, this is Alex.
Hi, this is Nathan.
And today we will be exploring the mysteries of the universe. Black holes.
Well, that's an interesting topic.
Yep, we're going to cover the black hole's anatomy, basics, history, information, and such.
We've researched a lot about black holes, so we may be able to answer any questions you may have. Black holes are objects with an insanely huge mass. It's made up of a huge amount of matter compacted into an extremely dense point.
A black hole is invisible to the naked eye until it absorbs an object in space, such as a star.
The size of a black hole ranges from 35 miles across in diameter and 75 miles across in diameter.
The speed that an object needs to reach to overcome the gravity of another object is called the escape velocity. This was the key to the first theory of black holes.
In 1783, an English scientist, John Mitchell, wondered what would happen when a star's escape velocity goes up to over 186 miles per second, which is the speed of light.
In 1795, French scientist Pierre Simon Laplace suggested the existence of dark bodies, now known as black holes.
Black holes were also theorized by Einstein, using the theory of relativity.
Starting out, a star is formed from a fast-spinning nebula. Contracted and heated, it spins faster and faster, and particles clump together into a spherical shape due to the force of gravity.
With all the processes that are needed to form a protostar, a star is eventually formed.
After a large mass star is born in the nebula, it shines for billions of years.
The only reason a star shines is because of nuclear fusion, a process that combines two of the same elements into a heavier element.
As the star creates heavier elements, the star begins to inflate and expand, making itself a supergiant.
Eventually, the supergiant will create iron. This means it only has one day to live before a supernova.
The leftover of the explosion is a nebula in a neutron star. Gravity will keep contracting the star until it eventually becomes a black hole.
Black holes do live a long time after its formation, but everything has to end eventually.
A well-known physicist, Stephen Hawking, using the quantum theory, predicted that very tiny particles in black holes are created and destroyed to evaporate.
Thus, the end of a black hole would take incredibly long, maybe even trillions of years.
There are three different types of black holes. The Schwarzschild black hole is the simplest out of all of them.
The event horizon marks the edge of a black hole. We call it this because no information about events occurring beyond this horizon can reach us, and not a single object, not even light, can escape it.
The more massive a black hole is, the bigger the event horizon will be. The singularity is the center of a black hole that contains the entire mass of the dead star.
Unable to withstand gravity, a star is crushed until it becomes a point of infinite density, occupying virtually no space. Every black hole has a singularity at its center. Usually, these lethal effects from a black hole stay close. Because the distances between stars are very great, most black holes that form would pose no threat to neighboring stars or their planets.
Essentially, if you were to get close enough to a black hole, about 10 miles, your body would be sucked into the black hole and be stretched and torn apart.
If you were watching an astronaut fall into a black hole, you would see the astronaut be spaghettified and would start to fade into a reddish color.
If this astronaut were to be wearing a wristwatch, you would notice that the speed of the watch would begin to slow down as he or she gets closer.
This happens because the hole's gravity is strong enough to distort space and time.
If you fall into a small black hole, you will most likely die because you're being stretched into much smaller space. But if this were a supermassive black hole, you might have a chance of surviving. Wait, you gotta see this. Nathan! Yeah!
Planetary Devastation!
Dude, you know it's never gonna work, right?
Nah, I think it'll work. Was it?
You watch too much Naruto, dude.
Okay, well, maybe I watched too much Naruto, but
that little ball
pretty
thing,
sure.
the little ball, it's not gonna suck us in. You'd have to be in space to do that.
Nah, I just think it'll work. Want to bet?
Yeah, $1 million. We're not gonna be able to see a little ball suck us in like a black hole.
So so what if I'm right and a black hole, or I create a black hole, and then it sucks us in?
Well, then it looks like you're not getting $1 million.
So either way, I'm not in a good position.
Yeah.
Wow. Okay. Fine.
Dude, you know that's never gonna work, right?
I need to focus.
Sure.
I feel something. Wait, what? What? Okay, never mind. It was like an insect or something.
Dude, just give up.
No.
What is it?
What is that?
It worked.
No way, dude. Wait. Give my family the $1 million. Because we're gonna get sucked in. As you know. We can't get out of here.
I don't have that kind of money, dude. I just said that because I knew it wasn't gonna happen. You're right. I didn't know you could do that.
Well, anything is possible, Nathan. Anything. That's the last words. You gotta believe. And you're not trustworthy.